Well, big yikes. I forgot about this last page, so let's quickly go over these last couple of problems. So, looking at the top of this last page, it says describe every transformation that maps each given figure to itself. So when thinking about questions like this, it's important to think about the lines of symmetry for the object. When we look at A, it's a trapezoid, and you may or may not remember that a trapezoid has one line of symmetry. And that line of symmetry would be like right here. So if it has one line of symmetry, there is only one type of rotation that would bring this figure back onto itself. So when I look at this one, if there's only one type of rotation that would bring it back onto itself, what is that rotation? It is 360. So this would have to go a full 360 degrees to land back on itself. So here, 360 degree rotation. And if we think about the reflection, well, could it reflect onto itself? So that's for rotation. Could it reflect onto itself? Well, yeah, it could reflect onto itself, but it would have to be over this line of symmetry. So this line of symmetry right here is at y equals -1. So it could also reflect over the line y equals -1. Okay, is that it? So rotation, reflection, translation. Well, translation doesn't really, that wouldn't be like back onto itself, reflecting over, oh, I wrote y equals -x, that should be y equals -1. But yeah, so that's everything for this trapezoid, and it would be over that line of symmetry. Going to B, this is a rectangle. So how many lines of symmetry does a rectangle have? It has 2. Okay, so I can see that there's a line of symmetry right here, and there's a line of symmetry right here. A line of symmetry just basically means that if you folded this shape onto itself, it would line up. So like you could imagine folding a sheet of paper, and like you just need the edges to match. So given this with 2 lines of symmetry, well, if I rotate it 90, would that be lined up with itself? No, not quite. What about 180? Well, yeah, 180, it would be lined up with itself. All the edges would match. So 1 would be 180 degree rotation. Okay, let's keep going with the rotation. So 180 works. What about 270? No, that wouldn't be lined up with itself. That would kind of be the same thing as 90. And then what about 360? Yeah, 360 will always line up with itself. So 360 rotation. A test question is really not going to give you a 360 degree rotation as an option, but we know it's true. And what lines could we flip over for it to be mapped onto itself to line back up? Well, we could flip over this line that we drew, the line of symmetry. That is the line y equals 1. So reflect over y equals 1. And then last one, what's the last line that it could flip over to land on itself? Yeah, like this one right here. So you could reflect over y, or that's not y now, that is x. It's going through your x-axis. X equals -2. Okay, so those are the ways that this figure could line up back with itself. So you can like think about it like rotating or flipping over those lines. And then here are our last two questions. And these are multiple choice. So this one says, what is the sequence of transformations that carry triangle ABC, so this one, this is our pre-image, to triangle SRQ, and this is our image. Well, what has occurred here? Before like even like looking at our answer choices, what happened? Well, a flip looks like it occurred, so a reflection. So I'm just going to write myself some notes down. A reflection. And after it's been reflected, it moved down. So let me focus the camera again. It's been moved down, so that means a translation has occurred. Translation. Now let's look at our answer choices. So A says a reflection across the line y equals 3. So that would be like, or x equals 3. That would be right there. And then it's translated 2 units down. So if it was reflected over that line, that would be like here, and then like 1, 2 down. Well, if that's the bottom of our triangle and it's only been translated 1, 2 down, that's not going to line up. So A, that doesn't work. I'll pause and let you think about B through D. Okay, so triangle ABC is reflected across the line y equals negative, or x equals negative 3. That's the same line that we were talking about, and translated 6 units down. So if this point was then translated 1, 2, 3, 4, 5, 6, well, that looks like it's going to work. This would be that point, and it would line up with itself. So it looks like the answer is B. Looking at C and D, it said translated 2 units to the left, then like rotated 90 degrees counterclockwise. And this one is like about the point 1, 1. So these seem less correct, and we already found our correct answer. So the correct answer is B. And then here we are on our last question. Which transformation on quadrilateral ABCD produces an image that does not preserve the distances between points and quadrilateral ABCD? What does it mean by not preserve the distances? I'll let you think about that. So not preserve the distances, that means like if this is our original distance, it either got smaller or it got bigger. So on this quadrilateral, it's gotten like bigger or smaller. So what type of transformation makes something get bigger or smaller? Look through A through D. Well, not a reflection, not a translation, not a rotation. Those are our rigid types of transformations. The only thing that could not preserve distance would be dilation by a scale factor of 2. So that's your correct answer, C. Okay, I promise that's the last of the Unit 1 videos, and I'll try not to mess up and break them up in the future. But go ahead and complete your exit ticket now, and I'll see you for Unit 2A.